Okay, so the next step, it's pretty much the last step, is using inverse operations. And to use inverse operations, you need to look at the, oh, you know what, there's a better way to say this. What we're trying to do is we're trying to eliminate numbers. So you eliminate numbers by looking at the operation that is acting on them. So if a number is being added, you look at that, that's the operation. Or if it's being subtracted, you just look at what's happening to the numbers. You eliminate numbers by looking at the operation that is acting on them and then doing the opposite operation to both sides of equation. So this is like a balance set 2, sort of. So in this case, I see that this is -1 times x equals -2. -2, there's no operations over here. It's just -2. But on this side, it's -1 times x. So if the operation is times, then what I'm going to do is I'm going to divide by the same number that I want to get rid of. Divide by -1. Now the reason I do that is -1 divided by -1 equals 1x. And then I'm going to do, because I divided one side by -1, I need to keep it balanced by dividing the other side also by -1. By -1. And so -2 divided by -1 is just 2. So then, so what I do, what I see there, I don't know why I switched these. I'm actually gonna try to fix that. I switched this. I'm gonna erase that so that we can keep it straight what side of the equation everything is on. So then this is going to become just 2, and the other side is going to become 1x. Now 1x is what you want. I want to know what 1x is equal to, and in this case, 1x is equal to 2. So if -1 is equal to 2, by the way, I don't know if you guys noticed that, but those are the only tiles that are left. -2 was the only one left, and then -x was the only one left. And then if I multiply by, if I divide by -1, that means I flip the tile. And if I divide by -1, that equals just flip the tile. Sometimes it'll mean flip the tile and also divide the tiles into pieces, but in this case, we're just flipping them over. So what I'm going to be left with is a negative, it's going to turn into a positive x, and this negative x is now gone. And then these -2 are going to go away, and they are going to turn into positive 2, like that. And that's my answer. So finally, this is called, so what we have now is called the solution. I buried it back here, but this is the solution. And the solution is the value for x that makes an equation true. So if I was to go back all the way up here and plug in 2 times 2, if I trade out the x and I say all of the x's are with 2, this side is going to equal this side. So if I did 2 times 2 and then minus 3 times 4 plus 2 times 2 plus 8, that should equal -3 times 2 minus 6. And then I could actually go ahead and figure that out. 4 minus 3 times, let's see, 2 times 2 is 4, plus 4 more is 8. So minus 3 times 8 plus 8 equals negative 3 times 2 is 6. So, or negative 6 minus 6 more. And then if I went up further, this would be 4 minus 24 plus 8. And that would equal negative 6 minus 6 is negative 12. So then 4 minus 24 is equal to, let's see, 4 minus 24 is equal to negative 20 plus 8, which is equal to 12. So sure enough, when x is negative 2, this side is equal to 12. Oh, sorry, negative 12. This side is equal to negative 12, and this side is equal to negative 12, and those match. So that is a way that we can check our answers, and I'm going to teach you that next.